Hello everyone, this is Dr. Jagannayaki, Associate Professor in MBA Department, Institute of Aeronautical Engineering, Dundigal. Today I want to discuss about sampling design. So in research process, sampling design, it plays a major role. So without sampling techniques and sample design, you cannot carry out your research process. So that is the reason I want to discuss about sampling design today. How to select a sample, what type of technique you are going to adapt in the selection of samples, everything I used to discuss today with you all. See, before going to enter into a sampling, first of all, I want to discuss about census. What do you mean by census or universe? Or you can also say it as a population. See, when you are going to consider all the items under study, then that is known as complete enumeration. It is also known as universe or a census inquiry. See, whenever you want to find out about the population details, we used to conduct a census survey. It means that we used to include each and every human being who resides in a particular country. So that is known as census inquiry. It is known as a complete enumeration. Now, all items in general, how do you define a universe or population means when you are going to consider all the items together is known as a universe or population. So, when we are talking about census inquiry or census survey, it includes all the items in a given population. Then, what do you mean by a sample? So, it is not possible to cover all the items or all the people in a particular locality or in a particular population. So it involves a lot of cost and time consuming activity. So instead of that, generally we used to take some units or some items from the population which we have chosen for the analysis. So this sample, it becomes the representative of entire population. So this small part of this population is known as a sample. So sample, it consists of the same characteristics of the population. So this type of groups, if you can choose more than one samples as well from the population, it depends on the nature of the study. So all the three, they are the representative of the entire universe and which are known as homogeneous characteristics. Homogeneous characteristics. So that is the reason we'll consider samples rather than population. Then the selected respondents to whom you are going to select, either it may be an item or individuals. So altogether is known as a sample. So the technique that is used to select a sample from the universe is known as sampling techniques. So it depends what type of sampling techniques you are going to use in the selection of a particular sample. Either you want to apply probability sampling or non-probability. Either you want to depends, it means randomly or non-randomly you want to select the sample from the universe. So it depends on the type of survey. So the survey so conducted is known as a sample survey. So every researcher, they must prepare a sample and that includes two things. One is how to select a sample. Another one is what will be the size of the sample. So whether you want to take a small sample or the sample size should be more than 30. So that is, it depends on the investigator. Then what will be the implication of a sample design? What are the things that we are going to consider at the time of selection of a particular sample from the universe? See, sample design, it is a definite plan for obtaining a sample from a given population. There are different types of techniques available. So it depends what type of procedure the researcher would adapt in his research survey. So the sample design, it should be like that. It should be more accurate and whenever you are going to select a particular study or a sample, that should be appropriate and easy to apply than other methods, whatever available. So it should be reliable and also it is useful for the research study. So in that way, we have to select the sample. Then what are the steps involved in sample design? So every sample design, it consists of some steps. The first one is we have to discuss about type of universe. See, a universe, it consists of a set of objects. So the set of objects, it may be anything. You can say that some object, some people, or some articles, whatever it may be. So all together is known as a universe or population. So the population may be finite or infinite. So finite means which consists of a few items that in a sample that should be taken from the entire population which possess the similar characteristics. So in case of finite means, for example, if you take the population of a particular locality, so we can easily assess what will be the number of people, those who are going to reside in the particular locality, and you can also count what is the average height of the people. So all these things we can measure in case of a finite sample design. But coming to infinite, it is very difficult to identify how many units available in the population. So it may not be possible. For example, if anyone asks how many stars in the sky, it is beyond our limits. So you cannot justify it. So there are certain things, it depends on the number of units in a particular sample. So basing on that, we used to divide the type of universe as finite or infinite. Then coming to source list or sampling unit. Sorry. So a sampling unit is that a geographical area you can take. See, it should be like you want to assess the economic position of a particular state. So how can we measure? If you want to measure the economic levels of or the standard of living of people in a particular state, then we used to further divide the state in terms of geographical area, district wise, then villages wise, colony wise, like that we used to divide. So here, or else sometimes if you are taking a construction unit as the example, number of houses, number of buildings, how many buildings are there, and how many villas are there, all these things should be comes under the sampling unit. Sometimes a social unit, sometimes we may take like an individual person also. So that is known as whatever we are taking as the sample, that is treated as sampling unit. The next one is source list or sampling frame. So how we are going to get the samples? What is the source to identify the sample units? So it includes the names of items, so which we have taken from a specific population, a specific universe. So that size, it is always limited in number. So that type of universe is known as finite universe. So it should be comprehensive, and whatever data you are going to select from the universe, it should be correct so that we can able to test the reliability, and it should be appropriate also. The next one is like the size of sample. Size means the number of units to be selected. So when you are selecting a particular sample, then how many units you are going to consider under that particular sample. So in general, the sample size should not be too large or too small. It should be optimum. So what do you mean by optimum? Optimum means it must and should satisfy the requirements of like efficiency, representativeness, reliability and flexibility. So we want to achieve the precision levels means by increasing the sample size, we can achieve the desired precision, and also an acceptable confidence level for the estimate. Then next one is parameters of interest. See, parameters of interest means what exactly you want to study. So why? What is the purpose of selecting a particular sample from the universe? So there should be some specific population you are going to consider and what type of interest they have. So basing on that, we used to adapt a sample. So in that sense, even we used to differentiate like uh, the specific population means, for example, you want to understand, you want to conduct a study related to some academic purpose. So when I am going to formulate one hypothesis that there is no significant difference between UG and PG students. So this statement in terms of efficiency or in terms of performance, academic excellence. So I want to study that particular aspect. So here my population, I'm very much clear because I want to test the academic excellence of both UG and PG students. UG and PG students. So this is my population. Then there starts, so I cannot study each and every individual unit fall under these two categories. So in that case, what I used to do, I used to specify some of the parameters. I'm very much clear. So which students I have to consider? UG, we have so many categories like normal degree will be there, BSc, BCom like that. Then BTech students will be there. So other type of classes they used to include under UG. The same case applicable in case of PG level also. So when I firmly decided I want to study the excellence, academic excellence of both BTech and MTech students, then start I used to work to whom I have to consider my target audience or respondents. Then if I decide a few of the colleges nearest to my college or my institute, in that case what I used to do, I'll consider some of the colleges in 2 or 3 colleges, and from that I will select randomly some of the students for the study. So that is known as random sampling, and I am very much clear about what to do, how to do, and to whom I have to select as my sample units. So here what I have to study, I am very specific in that. So out of my interest, I used to consider certain parameters to understand their academic excellence. Like I used to consider their marks. Sometimes I also conduct some sort of activities so that I can able to assess the performance of these students in different ways. So that is comes under the parameters of interest. The next one is budgetary constraint. So as we all know, research is an expensive activity. So it involves a lot of cost everywhere, right? From the selection of a sample, data collection, data analysis, everywhere it involves and it is connected with cost considerations. So the cost consideration, it depends on the size and the type of sample. How much will be the size of the sample? Whether you want to test only 100 people, 1000 people, 10,000. So that is known as size, number of units in a sample. And not only that, what type of sample you are going to consider, whether you want to consider random samples or non-random sample. If you are very much sure about random sample, then what will be the procedure? Which type of procedure you want to use in the selection of a sample? So all these things we used to consider in a sampling design. Then how do you select a sample or sampling procedure? See, basically, there are two types of cost involved in sampling analysis. One is cost of collecting data, another one is the cost of incorrect inference resulting from the data. See, first one is like cost of data collection. So always it involves a lot of expenditure. The other one is a wrong selection of a sample. Wrong selection of a sample. Again, it results into systematic bias. See, this is very, very essential. See, basing on your nature of study, you have to select a sample. Otherwise, it leads to sampling errors as well as systematic bias. See, the two reasons for selection of incorrect samples or inferences. One is systematic bias, another one is sampling error. See, systematic bias, it results from errors. So, where do we do the errors? In the sampling procedures. Instead of using one type of sampling procedure, if you are going with another one, then it leads to systematic bias. So, it cannot be reduced or eliminated by increasing the sample size. So, it may not be possible. Then, that is the reason what we have to do. Whenever you are going to select a sample, we should be very cautious at the time of selecting a sample from the universe. So always we need to apply an appropriate sampling technique. Then a systematic bias is the result of one or more factors. The first one is like inappropriate sampling frame. See, that's what I said. Whenever you are going to select the sample size, it should be accurate. We need to consider an appropriate sample from the universe. Otherwise, it leads to systematic bias. Then, detective measuring device. See, we have to apply suitable method to select a sample. That is another result of avoiding systematic bias. The next one is non-respondents. So it doesn't mean whoever you are going to include in the sample, each and every sample unit, they must respond to our questions. It may not be possible, maybe due to lack of time or due to some other reasons. Sometimes they never disclose the truth. So that also leads to systematic bias. Then indeterminacy principle. So in this case, sometimes we can find some sort of difference in terms of the people when they used to observe you, when you are under a particular task, and how you are going to behave under a strict supervision and without supervision. So that matters a lot. So during the supervision, if you feel that someone they are observing you, then the way you are going to respond, it may vary. When no control and no supervision, nothing will be there, you are freely, you can able to show your performance. So that leads to some sort of systematic bias. Then natural bias in reporting of data. So even it depends. Naturally, sometimes we may cause systematic bias due to whenever you're going to report something, sometimes people may hide some sort of things out of some prestige or something social status. So this may happen exclusively in terms of tax related things and all. So when they used to disclose the things to the government department, taxation department, their answer will be different. And when they used to move with their friends, family members, they used to discuss something else. So that also leads bias in the system. Then coming to the second one, another reason for incorrect inferences is sampling error. So sampling errors means random variations in the sample. So around the true population parameters. So this sampling error, it decreases with the increase in the size of sample. How can we get the accuracy or precision levels? just by increasing the size of the sample. Up to certain extent, we can reduce the sampling error. So, if you see that a smaller magnitude, particularly when you are talking about homogeneous population, with increase the sample size, the precision can also be improved. The accuracy levels of the sample also improved just by increasing the size of a sample so that we can reduce the sampling error. And characteristics of a good sample design. When we will say a particular sample is a good sample. So first of all, it must result in a truly representative sample. So always we used to take the sample from the same population or same universe under the study. Right? So it is the true representative of the population or the universe which is specified under the research. Then second one is sample design must be such so it must be in such a way that the results in a small sampling error. So there should not be much difference. You cannot find much variation. So that if you increase the size of the sample, naturally we can improve the precision also. So that's how we used to minimize the sampling error. Then next one is sample design must be viable in context of funds available for the research study. So whatever funds available with you within that limit only we can able to utilize those funds up to optimum level, and you can able to select the sample in a proper manner by using an appropriate statistical techniques, so that up to certain extent we can cover, we can also minimize the time, and you can also minimize the cost. The next one is sample should be like that. The sample study can be applied in general for the universe with a reasonable level of confidence. See how you are going to select. There should be some confidence level out of which you are going to select, because you feel that this particular sample is appropriate or more suitable to your study. So in that way, we used to select sample. So if a particular sampling design possesses all these characteristics, then it is said to be a good sample design. Then coming to the types of sample designs. So we have different types of sample designs. The first one is like probability and non-probability sampling. So some samples we used to select like in unrestricted way. In some cases, there will be some types of constraints in the selection of a sample. So that type of samples are known as restricted sampling designs. So probability sampling designs, it includes some probability. What will be the chance? So it is based on the chance. So in case of, this is also known as random sampling technique, where in simple random sampling technique, each and every unit will have an equal chance of being selected from the population. For example, if you have 10 balls of different colors in a bag, if someone asks you to pick randomly, so every time we used to pick one ball from the bag, so every ball will have the same chance of being selected 1 by 10. So this sampling technique is also selected in two ways: with replacement, without replacement. So with replacement and without replacement, for example, if you are going to pick a ball from the bag, immediately if you are going to put the ball again in the same bag, so every time you will have only 10 balls. There is no change. So whenever you are going to pick, you will get an equal chance of being selected. Every ball will have the same probability. But coming to without replacement, once you are going to remove one ball from the bag, you will have 2 by 9, 1 by 9. Already we have took one ball from the bag, so 2 by 9, next 3 by 8, next 4 by 7, like this. Every time you are replacing, without replacing the ball, you are picking one of the ball. So it differs how you are going to select the sample by using random or non-random techniques. See, in case of complex random sampling techniques, there will be different types like cluster sampling will be there, systematic sampling, stratified sampling, etc. So in case of clusters means grouping. So we used to group the samples by considering some sort of characteristics based on some homogeneous characteristics. We used to group as clusters. So that type of sampling is known as cluster sampling. For example, all BTech students, you are making them as one cluster. MBA students, another cluster. So like that, we used to form different groups by taking any one of the characteristic as the basis. Then systematic sampling, we used to adapt a systematic criteria in the selection of a sample. And stratified means we used to divide the entire population into different stratas. So like I'm going to define, this is first strata 1, strata 2, strata 3, strata 4, like this. So all the stratas will have equal size of samples. So this type of sampling technique is known as stratified sampling, and it is also one of the technique of probability sampling. And coming to non-probability chance sampling, so it is also known as deliberately we used to select. So it is known as deliberate sampling or haphazard sampling, convenience. So as per the convenience of the researcher, he used to select the sampling units from the universe. And purposive sampling is that with a specific purpose, whenever you are going to carry out a particular study, basing on the study only we used to select the samples. So that type of samples is known as purposive sampling. And some cases we used to have different quotas based on their categories. And judgment sampling. So finally, in this case, the researcher, he himself is the supreme of his study. So whatever way he want, he used to select the samples. Finally, it is judged by himself only. So that type of sampling is known as judgment sampling. So thus we can understand the types of sampling. It is based on two things. One is representation of the basis, what type of basis you are using, and how you are going to select the element, what type of technique you are going to use in the selection of a particular sample. Then basically we used to divide the samples into two types. One is non-probability sampling, other one is probability sampling. So in case of non-probability sampling, so the sample items are selected by the researcher as per his own interest. So because he is the ultimate decision maker of his own study, so basing on his own convenience or whatever may be the purpose, he used to choose the samples accordingly. So there are different types of non-probability samplings available. The first one is like deliberate sampling, purposive sampling, and judgment sampling. So deliberate sampling means according to the researcher, he used to select the sample, and purposive sampling means it involves some sort of purpose, and judgment sampling, finally the sample precision and all judged by the researcher himself. Then coming to this non-probability sampling design, the items for the samples are selected, and as we know, he is the ultimate whole and sole responsible person. So if you take one example, already I have told this example, if you want to study the economic conditions of people who are living in a state, they are to be studied like in different, basing on their geographical region. In towns they used to consider villages. So there is a purpose for this survey. It is an intensive investigation which is done by the researcher. So by dividing the geographical region into different types of zones, and he used to conduct his study. So the judgment of an organizer, it plays a major role in the sample design. So quota sampling is another example. So people generally they used to assign some sort of quotas. Basing on that, they used to select by considering different types of stratas, and those some instructions will be given by the researcher, and he suggests how they are to be filled. Then second type is probability sampling or random sampling or chance sampling. Probability means it is always we discussed about the chance. So every item will have an equal chance of being selected. So it ensures that the law of statistical regularity, it states that if on an average the sample is chosen is a random one, the sample will have the same composition and characteristics of the universe. For example, whenever you're going to pick a sample from the universe, see this sample belongs to the same population. So whatever the characteristics of the population, the same characteristics we also find in case of this sample also. So this is the reason why random sampling it is considered the best technique of selecting a sample from the universe. So it has certain implications. So the first implication is that it gives each and every element in the population an equal probability of getting into the sample. So here, even if you have, let us take a pack of deck which consists of 52 cards in a pack. So if you want to pick randomly one card, so all the 52 cards will have the equal chance of being selected. So this is the first implication. And second one is all choices are independent of each other. See, in case if you are going to pick one card, the card may be ace or it may be a king or queen, whatever it may be. But these cards, whatever we have drawing randomly, they will never have dependency on each other. No connection at all with each other. They are all independent of one another. And it gives each possible sample combination an equal probability of being chosen. So there it depends on what type of principle you are going to use, whether you want to go with replacement or without replacement. So in case of with replacement, every item will have equal chance of being selected. But without replacement, again it varies. Then how do we select a random sample? So there are different types of methods. When you're talking about a simple random sampling, so we'll have three methods. One is lottery method, another one is throwing a dice, and next the other appropriate method is use of random number tables. So lottery method generally we used to write the names of items on a small sheet, and all sheets we used to put in a box. We used to shuffle them thoroughly. Then from that we used to pick one sheet. So that how we used to pick random samples by using lottery method. And even in case of throwing a dice, so when you are going to throw a dice or roll a drum, so you cannot say what number you are going to get. On a dice, we used to have 1, 2, 3, 4, 5, 6. So when you are going to throw a dice, sometimes you may get 1, sometimes you may get 4, sometimes we may get 6. like that. So that's how we used to select randomly some of the sample units from the population. And in some cases, just by using random number tables, we used to identify the range. For example, 0 to 10 you are saying. So between this range, you may pick up any number that belongs to this category. So randomly we used to pick certain numbers. So these are the different ways of selecting a random sample from the universe. So these are all known as the simple random sampling techniques.
Like, share and subscribe. Hit the bell icon for more updates.